We're never going to stop exploring the unknown in air and space.
We have ignition and we have liftoff.
Response was normal also.
Voyager 1 has made an incredibly astonishing discovery. NASA's engineers couldn't have guessed that after more than 45 years, Voyager 1 would still be exploring space and transmitting feedback back to Earth. But not all discoveries align with what we had hoped for. The recent discovery, confirmed by Neil deGrasse Tyson, has left the scientific community puzzled as the spacecraft has detected the presence of 775 celestial objects. What are these unidentified objects? Could they be the handiwork of extraterrestrial beings or a malfunction on the spacecraft? Join us in this video as we explore how Voyager 1 recently detected 775 unknown objects passing by in space. Neil deGrasse Tyson is undoubtedly one of the most recognizable faces in the scientific community, often referred to as the internet's favorite astrophysicist. He made his official entry into the field when he gained admission to study physics at Harvard University. As an astrophysicist, author, and science communicator, Tyson has been a vocal advocate for expanding NASA's operations, firmly believing that the organization is currently underfunded to effectively carry out its crucial work. Moreover, he fearlessly delves into conversations about the universe's secrets predating our existence on Earth. As expected from a celebrity scientist, Tyson has had his fair share of controversies. One of his most noteworthy moments was when he boldly declared that Pluto should no longer be considered the 9th planet in our solar system. This led to the removal of Pluto from the lineup of planets at the Hayden Planetarium, with Tyson classifying it as a dwarf planet. However, in times like these, when the scientific community finds itself caught in a dilemma following Voyager 1's detection of a whopping 775 unknown objects passing through space, Neil deGrasse Tyson becomes the go-to source for clarity and truth. Keep watching for Neil deGrasse Tyson's shocking revelation on the nature and origin of these previously unidentified flying objects. Our magnificent Earth, with her vast oceans and towering mountains, is still only a speck to the rest of the universe. That's mind-blogging, right? Philosophers have long recognized this fact, but it wasn't until the 1970s that NASA scientists had the opportunity to prove it. This groundbreaking discovery was made possible by the alignment of the 4 largest planets in our solar system: Jupiter, Saturn, Uranus, and Neptune. Gary Flandro, a PhD student at the California Institute of Technology and part-time worker at NASA's Jet Propulsion Laboratory, stumbled upon this celestial phenomenon while charting the orbital paths of these giant planets. Flandro's calculations revealed an incredible find. In the late 1970s and early 1980s, the 4 planets would align like pearls on a cosmic necklace, forming a long arc with Earth. This discovery excited Flandro's superiors at NASA because it presented an opportunity to optimize the trajectory of a space probe to these giant planets. By utilizing the gravitational pull of each planet during flybys, a spacecraft could gain a speed boost, akin to being tugged by an invisible cord that snapped at the last moment, propelling the probe on its journey. According to Flandro's estimations, the repeated gravity assists from the giant planets could reduce the flight time between Earth and Neptune from 30 years to just 12 years. However, there was a catch. This rare alignment occurred only once every 176 years, meaning that a spacecraft would have to be launched in the mid-1970s to take advantage of it. Recognizing the significance of this once-in-a-lifetime opportunity, NASA embarked on the development of 2 spacecraft, known as Voyager 1 and Voyager 2. These twin spacecraft were virtually identical in design and purpose, but they were launched into space just 15 days apart in the summer of 1977. Voyager 1, launched on September 5, 1977, became an integral part of the Voyager space program, tasked with exploring the solar system and venturing into interstellar space for the benefit of humanity. For nearly 5 decades, Voyager 1 has communicated with the scientific community through NASA's Deep Space Network, receiving commands and transmitting valuable data back to Earth in real time. Thanks to the meticulous work of NASA's Jet Propulsion Laboratory, we are able to monitor Voyager 1's distance and velocity data. As of August 2023, The space probe is situated a staggering 24 billion kilometers away from Earth, making it the farthest man-made object from our planet. The JPL spearheaded the design and construction of Voyager 1, and it embarked on its journey from Launch Complex 41 at the Cape Canaveral Air Force Station, aboard a Titan IIIe launch vehicle. That's amazing, but there is more. Now, let's introduce you to the spectacular journey that led to the discovery of these 775 unknown objects passing by in space. How did Voyager 1's successful journey through space? Voyager 1 initiated its cosmic voyage only 2 weeks after the departure of its twin spacecraft, Voyager 2. NASA had a clear mission in mind for the probe to explore the outer planets, the heliosphere, and the interstellar medium. They were eager to uncover the mysteries that lay between the stars, and the Voyager mission was the ticket to realizing this dream. Right from the early stages of development, NASA scientists determined that the spacecraft had to make flybys of Jupiter, Saturn, and Saturn's largest moon, Titan. Despite Voyager 1 being launched later than its twin, it managed to reach Jupiter before Voyager 2. The probe delved into the stormy atmospheres, magnetic fields, and majestic rings of the gas giants. Thanks to Voyager 1, we were treated to detailed images of Jupiter's and Saturn's moons, capturing their awe-inspiring beauty. But the Voyager mission didn't stop there. The intrepid spacecraft continued its journey, venturing beyond the outer heliosphere and into interstellar space. On August 25, 2012, Voyager 1 achieved a historic milestone by becoming the first human-made object to cross the heliopause and enter interstellar space. 2 years later, in 2014, we received confirmation that Voyager 1 had indeed embarked on this incredible cosmic journey. During its interstellar adventure, Voyager 1 encountered a series of coronal mass ejections from the Sun, creating a mesmerizing third tsunami wave. This phenomenon lasted until December 15th of that year. It was Voyager 1 that granted us the first ever family portrait of our solar system as seen from an outsider's perspective. Additionally, it captured the iconic image of Earth, affectionately known as the pale blue dot. After bidding farewell to the heliosphere, Voyager 1 continued its mission of exploring the vast expanse between the stars. Astonishingly, the spacecraft's mission has far exceeded expectations. Originally anticipated to conclude many years ago, NASA's engineering team worked their magic, extending Voyager 1's mission until 2025. However, by that time, it is expected that the spacecraft will no longer have sufficient power to operate its scientific instruments. The engineering team achieved this remarkable feat by conducting a trajectory correction maneuver in late 2017, firing the TCM thrusters for the first time since 1980. This decision effectively prolonged the mission's lifespan by an additional 2 to 3 years. It's truly astounding to reflect on the achievements of Voyager 1 over the past 4 decades, considering that its launch almost faltered back in the summer of 1977 due to a premature shutdown of a part of the launch vehicle. As it continues its cosmic journey, Voyager 1 travels at an impressive speed of approximately 523 million kilometers per year, equivalent to 1 light-year every 18,000 years. Its incredible velocity would be futile without the array of instruments on board. The spacecraft boasts 16 hydrazine thrusters, 3-axis stabilization gyroscopes, and referencing instruments that ensure the craft's radio antenna remains pointed toward Earth. These instruments collaborate as part of the Attitude and Articulation Control Subsystem, AACS. Voyager 1 also possesses 8 backup thrusters and an additional 11 scientific instruments, including an imaging science system, radio science system, infrared interferometer spectrometer, ultraviolet spectrometer, triaxial fluxgate magnetometer, and plasma spectrometer, among others. While some of these instruments remain active, others are either disabled or defective. Voyager 1 was keen to achieve its one and only purpose to explore the expanse of space and transmit invaluable insights into the wonders that lie beyond our home planet. This is more than sheer will to explore space. This is impeccable design. What is it about this engineering masterpiece that has kept it running for more than 4 decades? Voyager 1 is more than just a spacecraft. It's a marvel of engineering that's defied the test of time. Created by NASA's brilliant engineers, This interstellar traveler boasts an impressive array of features that have allowed it to journey through the cosmos for nearly 5 decades. One of Voyager 1's standout features is its radio communication system. Designed to function even beyond the solar system's boundaries, this system relies on a massive 3.7-meter high-gain CAG grain antenna. This antenna serves as the vital link for sending and receiving radio waves, connecting Voyager 1 to Earth via the Deep Space Network stations. When direct communication isn't possible, Voyager 1 makes use of its trusty digital tape recorder, DTR, capable of storing about 67 megabytes of data for transmission at a later time. To put things in perspective, as of 2023, signals from Voyager 1 take a mind-boggling 22 hours to journey from deep space back to Earth. But that's just the tip of the cosmic iceberg. Voyager 1 was equipped with sophisticated cameras designed to capture celestial marvels, from distant planets to their moons and beyond. Interestingly, these cameras for visible light aren't automatic. They follow the instructions set by an imaging parameter table stored in one of the spacecraft's digital computers. While this approach served Voyager 1 well, it's worth noting that more recent space probes from the 1990s onwards have adopted fully autonomous camera systems. The brain behind Voyager 1's operations is its Computer Command System, CCS. This marvel of 1970s technology controls the spacecraft's various functions, including command decoding, fault detection routines, antenna pointing routines, and spacecraft sequencing routines. An upgraded version of the CCS originally used in the 1970s Viking orbiters, it's a testament to the lasting power of solid engineering. You might be wondering why Voyager 1 and its twin, Voyager 2, are still up and running despite the years. Launched into space almost 5 decades ago, these spacecraft have defied the odds. Their instruments continue to transmit data back to Earth. And this is no small feat considering their vast distance from our planet, over 14.1 billion miles away. How do they manage this incredible feat of longevity? The credit goes to NASA engineers who've mastered the art of power management and the use of redundant computer subsystems. They've conserved the spacecraft's power by shutting down non-essential systems, effectively extending its operational life. But it's not only about preserving the equipment, it's also about ensuring that the spacecraft can efficiently process scientific data. Failure to do so would risk losing these prized craft to changing conditions. Voyager 1 is no ordinary space probe. It's self-powered using radioisotope thermoelectric generators, RTGs. These nuclear batteries, also known as radioisotope power systems, employ a thermocouple to convert heat from decaying plutonium into electricity through the Seebeck effect. These RTGs have no moving parts, so there's little risk of wear and tear, making them ideal for harsh and remote environments. What's even more impressive is that these generators don't rely on solar energy, which is a significant advantage for missions into deep space. However, there's a catch. As the plutonium decays over time, the RTGs produce less power annually. This hasn't affected the overall mission, but NASA engineers took a proactive step to compensate for the power loss. They turned off heaters and other non-essential systems that don't affect the spacecraft's flight capabilities. But it doesn't stop there. To maintain Voyager 1's continued operation, scientists are now contemplating turning off one of its instruments. Voyager 2 is likely to be the first to experience this, as one of its 5 scientific instruments faces a potential shutdown. Voyager 1 hasn't faced the same scrutiny yet, largely because one of its instruments failed early in its mission. However, the decision to switch off a Voyager 1 instrument may become necessary in the coming months. Scientists are actively searching for an alternative solution to prevent shutting down any of Voyager 1's instruments. One possible safeguard is a voltage regulator that activates a backup circuit when voltage fluctuations occur. This backup circuit can draw a small amount of power from the generator, specifically reserved for such occasions. Instead of keeping this power in reserve, the plan is to use it for the operation of scientific instruments. It's a calculated risk because, ideally, voltage should be tightly regulated. But we must remember that Voyager 1's electrical systems have remained stable over its more than 45-year journey, reducing the need for a safety net. NASA engineers will closely monitor voltage fluctuations and respond promptly if they become problematic. This cautious approach may save Voyager 1 from losing another valuable instrument. Did Voyager 1 experience malfunction? Voyager 1 is back in the spotlight, and the scientific community was shocked when they found what the space probe transmitted back to Earth. The spacecraft has stumbled upon 775 unknown objects in the depths of space. This revelation has triggered quite a bit of concern because, truth be told, we know very little about these mysterious objects. What's even more puzzling is that the data initially sent back to Earth was a jumbled mess. It was like receiving a garbled message from the cosmos. Imagine the looks on the faces of the scientists at NASA's Jet Propulsion Laboratory when they realized they were getting these wonky signals from deep space. Their investigation revealed that it originated from the Attitude Articulation and Control System, AACS. The AACS is an onboard equipment that measures, reports, and adjusts the position of the Voyager 1 spacecraft in space. It has an antenna pointed towards Earth, which allows it to send data back home. Scientists discovered that the AACS had switched to sending its telemetry data through a faulty onboard computer that had been inactive for years. NASA engineers managed to resolve this issue by instructing the AACS to resume sending data through the correct computer. Now, NASA is once again receiving uncorrupted data from Voyager 1. However, the question that lingers in everyone's mind is, why did the AACS switch to using the broken computer in the first place? While NASA scientists have not reached a definitive conclusion, they have put forth a hypothesis that the AACS received a faulty command generated by another onboard computer. Yet they are unsure which computer or what fault could have caused this unusual occurrence. When Suzanne Dodd, project manager for the Voyager interstellar mission, was asked about the situation, she mentioned that they plan to conduct a full memory readout of the AACS and thoroughly analyze its operations. They believe that this approach will help them diagnose the problem that led to the telemetry issue in the first place. Nevertheless, NASA's Jet Propulsion Laboratory has emphasized that the AACS appears to be working fine, and none of the spacecraft's onboard fault protection systems have been triggered. Consequently, Voyager 1 has not been forced into safe mode, and its signal has not weakened. One possible factor contributing to this anomaly is the extreme temperature in space. The cosmic environment can be harsh and pose challenges to the operation of a spacecraft like Voyager 1. Cosmic radiation and significant temperature fluctuations are some of the environmental factors that could impact the electronic systems of the spacecraft and disrupt its operation. For instance, cosmic radiation consists of high-energy particles originating from distant stars and celestial bodies. These particles can penetrate spacecraft structures, causing electrical disturbances, data signal distortions, memory errors, and data corruption. Additionally, temperatures in these far reaches of space can drop to -202 degrees Fahrenheit, 130 degrees C. Moreover, Voyager 1 is exposed to micrometeoroids, dust particles, and fragments from asteroids and comets, which can severely affect its operation. The spacecraft's plasma wave instruments have consistently detected dust impacts as it ventured into interstellar space. Due to its high radial velocity of 17 km/s, when a dust particle collides with the craft, it is instantly vaporized and ionized, forming an expanding cloud of plasma that generates a voltage pulse in the electric antenna of the plasma wave system. These energetic collisions with interstellar dust grains can potentially cause damage to Voyager's operation. Although it has yet to be confirmed, the presence of interstellar dust particles may explain why Voyager 1 transmitted peculiar data to NASA. While all of these factors could contribute to the malfunctioning of Voyager's computer systems, it would be incorrect to attribute the root cause solely to these occurrences. What is Neil deGrasse Tyson's opinion on the 775 unknown objects? Neil deGrasse Tyson, the popular astrophysicist and science communicator, provided intriguing insights into the recent discovery of 775 unknown objects by Voyager 1. According to Tyson, the presence of these 775 unknown objects raises intriguing questions about their nature and origin. He believes there is the possibility that some of these objects could be remnants from the Oort cloud, an extensive region beyond Pluto believed to harbor icy bodies left over from the formation of our solar system. Tyson pointed out that these objects might have embarked on a remarkable interstellar journey, propelled by gravitational interactions with nearby stars or other celestial bodies. To understand the nature of these unknown celestial objects, Tyson referred to popular scientific theories. One theory suggests that Voyager the 1st of May have encountered rogue planets or interstellar objects. Rogue planets, or free-floating planets, are celestial bodies that do not orbit any star. These planets drift through space, often undetected, until they enter the observational range of a spacecraft like Voyager 1. Their discovery challenges our existing knowledge of planetary formation and dynamics. Tyson discussed the implications of identifying rogue planets and how they might reshape our understanding of the cosmos. Tyson explored how Voyager 1's discovery aligns with the trend of detecting interstellar objects, prompting inquiries about their prevalence and their potential role in the evolution of planetary systems. Neil deGrasse Tyson suggested that the 775 unknown objects could potentially be relics of ancient interstellar probes or spacecraft, now gliding through space. Apart from Tyson, some other experts have proposed that the event might have been caused by extraterrestrial beings. This captivating concept has been generating increasing interest within the scientific community, as many people are contemplating the possibility that it could serve as a plausible explanation for the peculiar incident. The hypothesis is founded on the notion that there exists an extraterrestrial civilization that surpasses us in technological advancement. According to this theory, these aliens possess a superior understanding of space exploration, and it is conceivable that Voyager may have inadvertently journeyed into their domain. It is possible that Voyager 1 ventured into deeper regions of space than conventional spacecraft typically traverse, which could elucidate why we have never encountered these extraterrestrial beings until now. Perhaps they are situated at distances beyond our capabilities of detection. If Voyager 1 really stumbled upon their territory, it would be natural for these mysterious creatures to attempt to take hold of the spacecraft, potentially resulting in its anomalous behavior. However, proving such an event occurred would present challenges, as our present technology is limited in its capacity to explore vast distances within interstellar space. Furthermore, how does one locate these alien beings who have likely remained hidden for countless millennia and have no desire to be found? While acknowledging the need for further scientific investigation, Tyson encouraged open-minded exploration of the intriguing possibilities. In considering the potential for extraterrestrial life, Tyson emphasized the importance of scientific inquiry. However, it all boils down to one question: what if aliens really exist and we have been looking in the wrong direction? Thanks for watching another episode of Beyond Discovery. While you're still here, click on the other videos you see on your screen right now.